Hello everyone, and a very warm welcome to this year's conference on behalf of the Society for the Protection of Ancient Buildings and the Sustainable Traditional Buildings Alliance. I'm Nigel Griffiths, Director of the STBA and your host for this morning, being the first of 3 conference sessions which we're running this year. Of course, this is the first time we've done our conference as a webinar, so my thanks to the team who've mastered the technology and got everything set up for us. We've got the leading experts in this field lined up to share their knowledge with you, so you can be assured of the highest quality, cutting edge information available. Please feel free to use the chat function to say hi to each other. Normally so much happens in the margins at our conferences. I'd like to hope that we can at least capture some of that spirit that always makes it so special. We'll take questions at the end of each presentation if we have time. And otherwise we'll save them for the Q&A session at 12:15. If you have a question, please use the question function, which you'll find at the bottom of the screen, and that's rather than the chat function. There's a lot happening at present in sustainability and retrofit. As a result of COVID, we have a government committed to boosting the economy, and they have identified the energy efficiency of existing buildings as a key target area for spending money. As many of us know, there are great dangers here, and rushed work tends to lead to unintended consequences, while often, of course, failing to achieve even the original limited aim. The Green Homes Grant in particular reverts to a single measure approach that doesn't consider interactions or health, heritage, indoor air quality, the list goes on. In other words, it's not the whole building approach that SPAB and STBA and our supporters all believe is required. To be truly sustainable, retrofit measures, I think, need to be appropriate to the type of building, and they must save more energy than they use in the installation. So materials and embodied energy are today's theme. I can see Peter Cox has now joined us, and with all that in mind, it's therefore my great pleasure to introduce Peter Cox of Carrick in Ireland. He also represents the international heritage body ICOMOS. So over to you, Peter.
Thank you, Nigel. Hi, everybody. So I'm going to talk today about a couple of studies that we've been involved in. As Nigel said, my background actually is chemical engineering and material science, and I've been working in the field of materials analysis and conservation for over 40 years now, and about 10 or 15 years ago, through the organization ICOMOS, which is the International Council of Monuments and Sites, I was asked to look at the impact that the upcoming kind of legislation and movement towards retrofit would have on our heritage and traditional buildings. And hence we set up a working group initially, but that turned in 2012 to what's called an International Scientific Committee. And we now have 78 members of that scientific committees from about 49 different countries and 5 continents. So we have a very wide knowledge, and we're sharing information, and we're hoping that that committee can develop some sort of liaison or partnership with STBA, SPAB, and any other bodies that want to do the same thing, which is highlight the dangers in ill retrofitting or maladaptation, as we call it. So we've been looking at this for over 10 years. And my overview really is an introduction to life cycle analysis, assessments, embodied versus operational energy, because I think traditionally up till now, everybody's been talking about operational energy and how how that will save the planet. Unfortunately, it won't alone. So we really do need to look at our built heritage, our built environment. And then I go through typical methodology for an LCA. And then we look at a couple of case studies, one from Norway, quite a good one from the US of A, believe it or not, and from the UK, where we most recently did a study for Historic England on understanding carbon in the built environment. And then I look at a couple of next steps. So the built environment in Ireland accounted for 22.7% of Ireland's total greenhouse gas emissions. It's probably higher elsewhere because we still produce an awful lot of electricity by fossil fuel. But the government here has produced a climate action plan, and it's, we believe, the first climate action plan that incorporates a particular sectoral element on built and archaeological heritage. And that certainly is working to our favor at the moment. But the government already are now at the stage of implementation, and they've enshrined it in law. So they're carbon proofing all government decisions and major investments, enterprise and services, and in the public sector alone, they're looking at reducing emissions from public sector buildings by 30% and adopt a mandate for climate action. It's helping since our latest election in February, which was finally resolved in about late March or April. We do have the Green Party as a coalition partner. So that is certainly helping, knocking and getting open doors within government within Ireland. So what do these three buildings have in common? They're all what we would say past their sell-by date according to modern use. You've got an office block on the left-hand side, you've got some social housing, which is now derelict, and on the right you've got a faculty within Trinity College, which was built as a temporary fix in the early 70s and never rectified, to be honest with you. And then what do these three buildings have in common? Well, they're gone or going, and demolition is one of our biggest, we think, sins, if you like, when it comes to carbon and particularly embodied energy. And we also feel that it would have been better to keep some or most of the elements of the existing buildings and adapt a new use or make changes that would suit and reduce the amount of embedded or embodied carbon that was actually demolished. And as you can see from the middle picture, it's not done very methodically, and most of it will end up on a dump site. So life cycle assessment really is an assessment of the environmental performance of materials from the raw extraction and manufacturing to the disposal and recycling. It is the cradle to grave approach of environmental assessment of buildings that we must take. So when you look at construction, the raw material extraction, processing, manufacture, transport, and then the construction, what we haven't included in there is waste of construction materials, which does happen on a reasonably large scale. But the transport alone, if you look at the history in recent times of our stone industry in Europe, whereas stone, granite now mostly comes from China, and there's huge carbon transport involved in that transport. And then operational emissions, heating, cooling, ventilation, power, lighting. Maintenance, which is often not ignored but not looked at seriously. And then retrofit. And if we use, and I know Tom is talking after this about the suitability of materials, but if we use the wrong materials in a retrofit, we're not only doing damage to the building, but we're doing damage to the environment as well. So we really do need to look at that. And then the end of life demolition. As I pointed in the first couple of slides, transport, and then recycling and landfill. And could we recycle more? I think there's a lot of porkies told in recycling figures, and that if you look at the UK's figure for recycling construction waste, it says it recycles 90-odd%. I am afraid I don't believe that quite. And we probably need more research and more information on that front. So life cycle assessment, embodied carbon. The carbon emitted during extraction, manufacture, transportation and construction of buildings, as well as maintenance and end-of-life emissions. And then our operational carbon, and we do have to take these two into account. We're not, up till now, everybody's been looking at operational carbon. But that is the carbon emission that results from the day-to-day use of building through energy consumption. And the reference study period, and this we argued and discussed and debated at length. But to be realistic, we took and agreed at the end that the reference study period for any of our studies would be 60 years. In the US, they've taken 75 years. But when you think 60 years is literally 1960, we have an awful lot of buildings that are a lot older than 1960. So perhaps this should be also looked at. And then life cycle assessment on refurbishment versus new build. Time zero with refurbished cases starts at the time of retrofit, not at the time of initial construction. Only current and future carbon emissions are accounted for, not the carbon which has already been emitted. And in some cases that, in buildings older than 60 years, perhaps they should get carbon credits, for instance. New build, time zero with new build begins with the demolition of an existing building, but doesn't take in the carbon footprint of that demolition, and then includes everything after that. EPDs, or environmental product declarations, were, I think, the first EN, well, you can see it at the bottom of the page, came in 2012, a direction from the EU with a European standard, which was actually more of a guideline than a standard, that all manufacturing companies should produce EPDs, or environmental product declaration. And these are based on global warming potential of the product or the manufacturing or the end user or whatever, ozone depletion potential, acidification potential, particularly when we're talking about our seas, and then eutrophication potential, which is pollution that goes into our inland waterways and creates algae that then kills or eliminates fish species. But a prepared for LCA consultant, these need to be prepared by LCA consultants. The problem we're finding, and I'm sure other people on this call are finding, is that not many companies are actually producing EPDs. It's not regulatory, and therefore it's voluntary. And some good companies are doing it, other companies are doing it, and again, telling porkies about the performance. And we had a technical sales guy come into our office and show us some paint and say that it was carbon neutral. And I said, well, what about the plastic tub that it's sitting in there? And, where is it manufactured? In Germany. He said, well, there's a carbon footprint bring it from Germany. So I'm sorry, it's not carbon neutral. So we really do need to get to grips with this. And I think, and I believe France is the first European country to introduce actually legislation that from April of next year, I believe, all companies manufacturing in France will have to produce EPDs. Which will be really helpful to assessing and for us from a professional point of view to get the right information so that we can make the right decisions. The global warming potential is one of the key factors, and this is really what again we should be looking at. And then the classification or the LCA modules are the important, or is the important information that we need to then move forward into designing low carbon solutions for either retrofitting or for indeed for new build. Pardon me. Databases we found are lacking information, although the inventory of carbon and energy is an extremely good one, and it's been kept up to date, which is fantastic, and it is a great resource. The BRE Green Guide is good, and then the RAP Embodied Carbon database is getting there as well. The ICE, which isn't the Institute of Civil Engineers, but it's the Inventory of Carbon, is easily accessible, provided environmental impact in CO2 equivalents and many commonly used materials, and only 3 LCA modules, and this is where we really need to change. And these are just some examples. They're hard to read there on the slide, but you'll be getting this copy of this for more kind of study later, if you like. But calculating embodied emissions is a process, and quantity of material, emission factor of material, material waste factor, and then number of replacements within the represented kind of study period. And this is where a lot of people, and I mentioned maintenance is often ignored or not taken into consideration. But if you replace, let's say, sash timber windows with UPVC windows, you know, they really only have, they're very, very efficient in the first 5 years, pretty efficient in the second 5 years. And then they start degrading and they need to be replaced usually in around 25 years. So you must also take that into consideration, and that will give you the correct embodied emission of materials. And then the sum of all materials embodied emissions equals the building embodied over the research study period. Calculating demolition emissions, as I say, is difficult because there isn't a very good database for this, or it's not recorded. A lot of people just demolish and dump locally and don't record where it actually goes. There is emissions intensity of construction demolition waste, landfill recovery rates, emissions intensity of landfill equals really demolition emissions. And again, we need to really get some good handles on this information. And then calculating operational emissions, CO2 equivalent emissions, intensity of fuel. And we know most national countries or governments are actually driving, you know, to produce a lot of our energy by renewable. But we're still a way off on that. But even with renewables, there is an emission or a carbon cost. I mean, the big wind turbines have to be manufactured, solar panels have to be manufactured. So the end product might be, low carbon, but we have to look at the whole life cycle. And then the quantity of fuel used equals operational emissions. Most of you know all this, but I think what I'm getting to is that the study that we have done, or studies that we have done, we have not found an LCA tool, a life cycle analysis tool, that is absolutely suited to existing traditional or heritage buildings. Most of them are designed for new construction, and they're fine for that, but it's very, very difficult to get the right information to put into an LCA, and I'll cover that towards the back end. So Villa Damen is a 1936 timber frame house, typical of the Norwegian ordinary house typology. Energy retrofitted in 2014. The interventions included waterproofing windows and doors, insulating the pipes and domestic water heater, and installation of a wood burning stove. The occupants also altered their heating management by using temperature zones during heating season and reducing the set point temperature when the house was unoccupied. And one of my colleagues said, buildings don't use energy, people do. And I think we have a lot of education to do with people on how to run our buildings, particularly our existing ones. The base case, we look at the base case, a refurbishment, then demolition and new build. And in most cases, refurbishment saves, in this case, 295 tons of CO2 compared to base case. And new build emissions only 8% lower within 60 years compared to refurbishment. New build takes 52 years for the low operational emissions to outweigh the high embodied emissions compared to refurbishment in new build. And this is a graph that shows this. I think my photograph's in the way there, but you can see the circle there where it takes 52 years to pay back. The type and quantity of materials used, and again, Tom is going to cover this in the next one, and that is a really, really important part of all this. And by sourcing local materials, life cycle emissions can be reduced. In the 1800s, early 1900s, we used local materials. Data on materials used in refurbishment of historic buildings should be strengthened. We must understand about all the side effects that the wrong materials can affect building materials and building fabric. And then we need to educate city planning authorities, because in recent times we've specified products that the planners come back and say, well, we don't know this product and we don't want it used on this building. Which is pretty bizarre, but so we do need to start an education process. Occupier behavior, as I said, is also very important. In the USA, there was a case study done, which we peer reviewed and had a look at, and it was a large scale study, 6 different typologies across 4 different climates in the US. Building reuse versus new construction, renovated, best renovated, new build, best new build. For a period of 75 years, they chose, as I say, as their study period. And then 4 indicators: climate change, human health, ecosystem quality, and resource depletion. And again, this it's referenced in the final slides, so people can actually download it later. So building reuse almost always yields fewer environmental impacts than new construction when comparing buildings of similar size and functionality. And this is the US study on impacts of renovation. They took commercial office, warehouse, and two office, mixed use, elementary school, single family use, multifamily use, and a warehouse to multifamily use. And the findings are quite encouraging and very good, and I encourage you to have a look at that later on. But it effectively concludes that reuse matters, improved life cycle inventory data, a better understanding of material impacts, quantity and type of materials used matter, balance between carbon and other indicators is required. And in most of our EPCs or BERs in other parts of Europe, building energy ratings, we don't look at carbon at all. And in fact, in a lot of cases for traditional and heritage buildings, the default, they have a default for solid wall construction. This has to be changed. It really does, because all the research in Scotland, in UK, in England, in Wales, here in Ireland, where we've actually physically measured U values of traditional or heritage buildings, they always perform much better than the default that has been set by these tick box situations. And we do, that's another kind of whole hour's talk that you could get me going on, but let's not do it now. Our case study in England featured five buildings in the end, but the ones that we concentrated on really was a Victorian terrace refurbishment. Case study 2 was a chapel conversion from a small chapel to a private residence, and then compared to a standard new build meeting 2019 building regulations. And then the carbon emissions and costings compared between each case study and the new build. And again, this study is on the Historic England website and can be downloaded and looked at. But in very brief, the base case, no refurbishment, doing a refurbishment, and then doing a demolition and new build. The Victorian terrace refurbishment and the chapel conversion together saved about 260 tonnes of carbon compared to the base case. The demolition of the Victorian terrace refurbishment and chapel conversion account for 4.1% and 6.2% of the respective new builds' total carbon emissions. So it's quite stark. And looking at some of these charts, the base case obviously is full of embodied energy and only uses operational. The light refurbishment uses increases the carbon somewhat by interventions, and then the new build has a much larger size of carbon. And the life cycle emissions then, just looking at those, the conversion. So again, a chart, and you can see the dark dotted line is the new build, and it's very carbon intensive when you build it, and then it slowly works out. But again, if you take a new build against a good retrofit, it's going to take you 63 years to pay back the carbon of that new building. So we believe these are strong arguments and facts that we can now start using to gain traction, if you like, for policy change. In the case of the conversion, again, the new build, it's about 13 years of a difference. But again, as more products are made more environmentally, that will change also. And this is perhaps using high carbon insulation, for instance, rather than a wood fiber board. But these projects were actually done before we had any influence in changing their mind. What we'd love to do as a follow-on study is to take maybe 10 buildings and actually specify what should be done, and then implement and then monitor, and to get real hard data. So the conclusions really are: deep energy efficient refurbishment of historic buildings is necessary. When I was involved through ICOMOS in writing the EN European standard on deep retrofit of historic buildings, EN 16833, I think it is. And when we did the study there, we found that on average about 34% of our built environment is pre-1945. And that is a massive share of our built heritage. And there's a great video which Bill Gates does on saying that to house everybody in the world as the populations and urban people move to urban areas, we're going to have to build a whole New York City every 4 years. And if you think of the carbon kind of input into that, it's pretty scary. So the quantity and type of materials matter. Simple, a simple to use LCA tools, which is designed for the concept design stage, is essential. And EPD should become mandatory for all building materials. So what are the next steps? As I say, an LCA tool, and we are working on that. We've got some funding from the Irish government to develop a prototype to look at, and we have some external European investors as well. So we're hoping that we might be able to move that forward, and we'll certainly let STBA and SPAB know if it comes to fruition. But it's essential at concept design stage. It's too late coming to us or any of the professionals with a designed building, because then it's very, very difficult to make changes. So carbon really should be studied at the very first. So if we can get all these and get materials, material building manufacturers must have EPDs. We're really lobbying the Irish government at the moment to try and make that mandatory next year. And then we've got to also think about the circular economy, and can we design for reuse? And I think we can if we put some thought into it, but we also need to perhaps start the education process early on in architectural schools and engineering schools. And value of waste must be recognized. Tax incentives are good in some cases. They don't always work, but they certainly should, and should be introduced to encourage material reuse. Or linked to that, city and county councils could provide the skills to facilitate sustainable decisions. And we need radical policy changes to enforce this. And part of our conclusions on our recent studies is that perhaps we should be introducing, I mentioned it earlier, as a carbon. Nobody likes the word tax because we all think we have to fork out money. But if we say introduced a demolition fine, so there is an economic cost to demolishing a building, I think it could tip the balance. We should be looking at any building older than 60 years should have actually carbon credits, which then could be used against mitigation against use of carbon, other carbon new products or whatever. And we do need a kind of a sea change in this area. So what can we do? Be aware of the carbon footprint of materials that you use, specify, or recommend or indeed manufacture. If you can't find EPDs, request them from the companies, and the more requests they get, the more they realize they will have to start, complying and have this data. And then sell sustainability. We've got to really make people aware who are commissioning or developing or housing associations. We're working with a lot of housing associations at the moment to see how they can do more sustainable development. And then so thank you. That's the end of my talk. And I think questions are coming later, Nigel. Is that correct?
Well, we do have time for a few questions actually now, Peter, because we've got 5 minutes. So we've had 4 come in. I think the first 2 are very similar, and they relate to the health impacts. And you mentioned that conversions perform worse in health terms than new build. Could you elaborate a bit on that, please?
I was hoping you wouldn't ask me that question.
Not guilty.
We think it came up in how we assess the buildings that we looked at, and I have to say we wanted a lot more buildings to look at and a bigger range of buildings to look at, but these buildings were already in train or close to completion, so we were trying to evaluate what what was done. As I said at some stage, if we could get in at the earliest possible stage and actually specify what you should be done or doing, and most of it, the refurbishment or the health issue is more to do with Tom's subject next, which is using the wrong products. So if you have a breathable building and you put unbreathable insulation on the external of a building, you're going to create mold growth, and you're going to create moisture problems within the building, because you're playing with the interstitial movement of moisture, and that is the biggest fault. Whereas if in the case study that we looked at had used, let's say, wood fiberboard, and breathable materials, that wouldn't be the case. So I think this was a little glitch in our research, but we felt it was good to say it because it points that if you use the wrong products, you're going to have health problems.
Okay, thanks for clarifying that, Tom. One from Laura Milbourne. I think this will be a fairly easy one. Presumably VAT relief should apply to existing properties rather than new builds.
Absolutely. I mean, I cannot believe that. In at least 4 countries across Europe, conservation or preservation is at a flat rate of 5%, whereas new build is between 19 and 21%. England, I don't know, does it apply to the whole of Britain, or is it just England where new build is 0?
I'm pretty sure it's UK wide.
Yeah. And we think that's appalling, and I know Historic England are kind of bashing at the door on that one.
Yes, all we want is a level playing field.
Yeah.
Just it's a fairly simple technical question. What percentage of buildings are pre-1945? I think you said 30-something%?
It's about 34%. Okay. Now that we looked at the 28 countries of Europe, and sorry, that's only dwellings. That's not actual buildings. So if you add in early churches, let's say, education buildings, state buildings, you're closer to the 50%.
We tend to use the 1919 cutoff period
I know,
in the UK, but in Europe they use 1945.
Yeah.
Okay. One from Antonia Kayat. A USA study said that conversions perform worse on ecological biodiversity than new builds. Again, could you elaborate on that?
No, I can't. And we tried to look into the finer details of that, and we never got an answer to it. So sorry.
Okay, lovely. Just got time for the last 2. I think Chris Whitman asks, was mental health taken into account in the study? That's a very good question, actually.
It is, particularly now, it is, but it wasn't. And I think perhaps it should be.
Okay. Christina Newnham asks, we've had some issues with getting insurers to approve the use of natural insulation materials due to fire concerns. It might be one for Tom rather than you, but any investigation that you're aware of being carried out?
We're finding that they are coming around. We had those problems maybe 3 to 5 years ago, but with the larger now manufacturers coming out with natural products, they tend to have the wherewithal to do fire testing and things like that. I think that was, and it was like my comment about planners. If they didn't know the product, they didn't want it used, and that, but fire is a major issue. And I suppose it's something we've battled certainly over the last 10 years. The fight between the fire officer and the conservation officer, and who wins.
Well, we've got another question on the same kind of subject. Our biggest obstacle, this is from Best of Line, to retrofitting external upgrades, particularly wood fibre, is dogmatic local conservation officers and historic England on star or grade 1. Well, should we be moving on from preservation of a particular aesthetic, or are we going to live with poor thermal efficiency on listed buildings?
I'm on the side that we have to move on. I'm also on this for renewables, and to me, if you have a historic building and a storm comes and damages half a dozen slates, you get up and change them, renew them. What's the difference in putting a solar panel on a historic roof that is reversible? And all it does is create 2 little holes in your slate, which you can change anyway. So yes, I think there needs to be a change, and we need to be taking educating our conservation officers and heritage officers in that way.
Well, thank you very much, Peter. The last couple of questions we'll take in the Q&A session at the end. Personally, I find it fascinating. It could be over 50 years for new build to overtake refurbishment in terms of embodied energy. And that of itself makes a mockery of our 2050 targets, which are only, of course, 30 years away. So what I take away from that is it's about big picture thinking. It's about multiple metrics, and let's get this whole thing back into perspective. Thank you very much indeed, Peter.
Okay, thank you. Thank you.
Also now my great pleasure to introduce Professor Tom Woolley of Rachel Bevan Architects, Anglia Ruskin, and also the Centre for Alternative Technology. Tom is also the author of the Green Building Handbook, so he is absolutely best placed to talk to us about the kind of materials that we are using in retrofit. Tom.
Right, good morning. So like Peter before me, I'm not that used to doing all this share screen stuff and so on, so we'll hopefully that will work. I'm very pleased to be taking part in this event, and I really enjoyed Peter's thing, particularly because he's helped me out with the problem. I've been trying to think of a nasty name for EPDs, and he's given it to me now. They're called Environmental Porky Declaration. That's really helpful. Thanks, Peter.
No.
Shall I go? I'll share my screen now and see if it works.
And Peter, if you could stop sharing yours.
So are you getting that now?
Not yet. Maybe that's better.
You got it?
Yes.
So it's gone on to slide 2 for some strange reason, but that doesn't really matter. I'm going to talk, as has been implied from the previous presentation, more about materials, but I'm going to try tying it back to the whole issue of embodied energy or embodied impacts. And much of this is a rant against plastic petrochemical insulation materials, so I should apologize for that straight away. So I'm struggling now to, oh, here we go, advance here. So if you'll forgive me for just doing a little bit of advertising in case you don't catch up with everything I'm talking about today, here are some books, publications, including a recent article in the Cedar magazine about hempcrete. I'm also writing a series of articles in the RICS Built Environment Journal covering some of these issues as well. So a point I suppose I want to get across in terms of embodied energy is that people tend to think of it in terms of CO2 emissions and life cycle analysis and so on. And it can start to get a wee bit boring and academic because it involves a lot of calculations. But the important thing to realize is if we're using high embodied energy materials is that we're also causing pollution. And that pollution is not just CO2 emissions, but it's also other kinds of pollution. And here's a very, very vivid example where factories in Europe that have been producing isocyanates and other chemicals to make plastic foam insulation have been shut down. This is one in Spain near Tarragona. I won't go into the details, but you can see in the slides the kind of problems that exist. Also, there's a big factory in Ludwigshafen was also shut down where there was a big fire in the isocyanate factory that killed 2 firefighters. And so it's very important to understand the issue of the relationship between embodied energy. And of course, what happened when these factories got shut down was that there was then a shortage, which was well advertised in the press back in 2016 and 2017, that there was a shortage of plastic foam insulation. And that was because of the problem of shutting down these polluting factories. And what people are using in buildings today are high embodied energy, hazardous petrochemical materials that damage health and the planet. But unfortunately, what I call the energy efficiency zealots continue to promote these materials because they say it's the only available technology. And that the implication is that other alternatives are not readily available. So here we go. Here's some of the sort of examples of what people are doing to, particularly to try and retrofit buildings using these plastic foam materials. So because of this clampdown on toxic pollution in Europe, particularly in the manufacture of isocyanates, the manufacture then moved to China, mainly to Asia as well, other parts of Asia, India and so on. But and what that led to directly was a massive increase in CFC emissions. So when people talk about embodied energy, they are talking about CO2, but they forget about things like CFC emissions. Now, CFC emissions were banned in the Montreal Protocol in 1992, but we're now getting, there's been a 25% spike in these. And this was very brilliantly exposed in a report by the Environmental Investigation Agency called Blowing It. And here you can see a map where they're tracking the CFC emissions. So this is a direct result of the shift in production of these toxic materials to China. But these are the materials which are being imported into the UK and Ireland to manufacture plastic foam installations. But the other big problem that we face, and I realize Peter's already touched on this to some extent, but is the fact that we don't have good data on embodied energy. He mentioned the ICE database, which is, it's great that it's there, but it is weak. And if you, particularly if you try and look for data on the embodied energy of insulation materials, you'll find it very difficult to get good information. And there's a couple of pieces of work done by Callum Hill and others here, which do give you some information, but it is a problem because we don't have enough data on this. And again, this is a complete repetition of what Peter was talking about, is what Jukka Heinonen in Finland called the carbon spike, in which he showed how the emissions are due to the energy which is being consumed at the manufacturing and construction stage, not during the life of the building. That is the real problem that we've got, is not trying to make buildings more energy efficient for the future, which I guess is something we should do, but the important thing is to reduce this carbon spike problem. Another good person who's done a lot of work on this is Simon Sturgis, and he's he made very interesting critique of the Green Construction Board route map, because it fails to take account of whole life emissions and the need to adopt a holistic approach. He gives some data on this, well worth reading. And then the other thing which Peter mentioned is that if we use the wrong materials in buildings, particularly in retrofit, then we end up with these kind of problems. So we've got problems with cavity wall insulation, internal wall insulation, and external wall insulation. And one of the reasons we're having these problems is that the organizations that are calling for retrofit and zero carbon and Green New Deal and so on, largely ignore the issue of insulation. And I've been doing a study. I'm now up to about 60 reports on zero carbon and retrofit. And every single one I look at says nothing about insulation. So here we've got a range of documents that have been produced to argue for the importance of these sorts of things. And insulation is never mentioned other than very occasionally, and then usually in the most general of ways. So we need to insulate buildings, that's what they say, but they never go into any detail. None of them go into any detail. That's what's shocking about it. Here's a whole stack more of them. It really is quite baffling that people can write reports about how we need to renovate and retrofit buildings and not even mention insulation. That has to say something about the fact that people don't understand the issues. Perhaps the worst of all is the UK GBC document, Net Zero Carbon Buildings, which doesn't mention insulation once. Interestingly, the House of Commons energy efficiency building towards net zero and the much maligned Each Home Counts report do actually go into insulation in quite a lot of detail. So that's good. It's good that somebody's actually addressed these issues. But the problem we're facing in the UK, I'm not so sure about Ireland, is what's becoming known as the retrofit disaster problem. And here's a couple of interesting quotations. There's someone working at Bridgend Council delivering our bed schemes. He says, we were merrily cladding buildings, filling cavities full of insulation. 5 years later, we've got companies setting up now to take the cladding off, take the insulation out, because we realized that actually either wasn't the right thing to do, or the skill set that delivered it wasn't properly skilled or done in a rush. And this is becoming a massive problem, which is beginning to get into the media. There was a report about this in the Sunday Times quite recently, though it focused really on cavity wall insulation problems. And obviously there's been a response to this. We're now expected to comply with PAS 2035. I'm not sure that PAS 2035 will solve the problem, because it doesn't deal with the issue of materials, and it certainly doesn't deal with the issue of embodied energy. So here's just a few other horror pictures from the retrofit disaster problem. I won't spend a lot of time on this because some of you will probably be familiar with this. Perhaps people are particularly familiar with Fishwick and Preston, and the NEA did a webinar about this the other day, because they're trying to deal with some of the problems here. But I've got a lot more stuff on this if people are interested in it and not familiar with it. It's a particularly shocking example in Carmarthenshire in Wales, where external wall insulation was put on. I love the picture in the middle of the plastic over the window to channel the water that's pouring into the house as a result of wrongly or inappropriate external wall insulation. And some of you will come across these sorts of images as well of the kind of mistakes that are made when this kind of work is done. But this is inevitable in a way because of using the wrong kinds of materials. The other problem with the wrong kind of materials is using flammable materials. So one of the problems with petrochemical insulations is that most of them burn. Some of them burn more easily than others. And of course, people are familiar with the horrific story of Grenfell, but what tends to get ignored is the serious problems in lower-rise buildings, in which there are literally dozens and dozens of fires, all of which, in my view, are a result of using flammable petrochemical foam insulation materials in buildings. There's also a problem with poor insulation of fire stopping and so on. It's a very interesting example of the problem in Germany, where they have retrofitted a huge number of buildings using polystyrene external wall insulation, and the fire brigades in Germany are now refusing to fight the fires in these buildings because of the toxic emissions and the dangers caused by them, and they're calling for the polystyrene insulation to be stripped off. There's an example from London, just on the left there, of tower blocks that have been in Tower Hamlets, I think, where the polystyrene's been taken off. So this is a massive problem because millions of pounds have been spent, billions of pounds, on wrongly retrofitting buildings with materials. And these materials also should not be going into landfill when they get stripped off. It's hard to tell what actually happens to them. So one of the problems I feel that we currently have is that even when there are good reports done about the importance of retrofit, such as the Bristol Guide to Solid Wall Insulation, and there's this very, very good piece of work done by Mr. Heath, who, I'm not sure if he's on this webinar, but we talked about this the other day. And one of my concerns about this is that these documents and reports advocating the case for vapor open materials are not explicit enough and are not warning of the dangers sufficiently of the use of materials. So the picture on the right of the EWI is in Blackpool, where they use polystyrene insulation, and that's leading to problems. So I believe it's important to be much more explicit about the need to use the right kinds of materials, and we have to be using vapor open materials, and these materials by and large have much lower embodied energy than the petrochemical materials that I've been criticizing. So here we've got some examples of wood fiber insulation, which is being increasingly used, though one of the problems with wood fiber insulation is it's being imported from Europe. It's not manufactured here in the UK. In fact, hundreds of thousands of tons of wood waste go to landfill in the UK every year, which could easily be used to make wood fiber insulation, but that doesn't happen. Those of you who know me know that I'm obsessed with hempcrete, because I think hempcrete is the answer to all problems. And here's a few images of projects we've been lucky enough to do workshops around the country, particularly with the Irish Hemp Cooperative in Ireland, and also with the Carbon Co-op in Manchester. And here you can see some examples of where hempcrete has been applied to traditional and historic buildings, providing a breathable, insulative solution to a problem which is extremely low embodied energy and allows the buildings to breathe, and really also deals with the moisture problems as well. Here's some an example of a house in Enniskerry in Ireland, and workshop done with the hemp co-op. So the level of interest over the last few months in hempcrete has gone up considerably, and it's taking up a lot more of my time at the moment, because even in Northern Ireland now we're getting people interested in it, as Northern Ireland generally is 20 years behind the rest of the planet. That's quite encouraging. The supply of hemp is not really a problem. People often say that this is a difficulty with using natural materials, but we've got some great suppliers, particularly in Yorkshire. We've got Harris and Spinks, who make wonderful mattresses using hemp and natural wool, but they also can process a great deal of hemp. And in fact, there's plenty of hemp to go around with the companies available, though obviously production could be increased as more and more people are growing hemp in England in particular. We use at the moment lime binder, and there are a lot of lime binders being imported from France and elsewhere, but we have homemade lime binders, one that is made for us by Kilwater in Northern Ireland, and there's a new lime binder coming on stream soon for hempcrete from Lime Green in Shropshire. So the supply chain is kind of there, but we need to obviously increase the amount of production. So just to finish off, I want to show a couple of examples of work that's been done that's looked into this. This is a really excellent study that was done by Roseanne Walker at Trinity in Dublin about a building in the Royal Hospital in Kilmainham, where they actually experimented with a number of different kinds of materials. And there's a lot more information on this than I can show here, but you'd need to ask Roseanne for it if you want more detail. But she was able to compare the use of cork lime, hemp lime, and they even put PIR boards on the wall to see how they performed. And there's a fair amount of data on this, but what it shows is that the breathable cork lime and hemp lime materials performed far better than the other materials. The PIR insulation boards, which is being used a lot as internal wall insulation in the UK, was completely off the scale in terms of its inability to deal with water and moisture, and even in terms of its thermal performance. And we need more of these kinds of studies. We need the data that shows how these materials perform. The other thing which I've been doing some work on, which has not advanced as much as I'd hoped due to lack of funding, is the use of a clay binder with hemp rather than lime. That house on the right is Tom Morton and Becky Little's house in Scotland, where they've used hemp and clay, and we've experimented with using hemp with clay and found that it works amazingly well. Obviously using clay rather than lime means it has even a lower embodied energy. And the other thing to finish off with is the important issue of health. It's really, really important to ensure that we protect people's health, and we don't put poisonous chemicals into their homes. You can see there this robot spraying plastic foam insulation underneath people's floorboards. I cannot think of anything more horrible to do than that. There's a very good report done by people at UCL about the emissions from PUR and PIR and flame retardants and so on. Very important study, well worth reading, which looks into the the other interesting piece of work that's been done by Richard Sharp and others at Exeter showed that people's health got worse as a result of retrofit schemes, not better, which is often claimed. So there's some important work there. I got the slides slightly out of order here. There's quite some good work being done by a thing called the HEMAC project, Health Effects of Modern Airtight Construction, if people aren't familiar with that. And also some very interesting work done by Ian Mordett. So there's a lot of information starting to come out. So looking at the time, I think I'm just about on time. The argument really is that if we can use natural, low embodied energy, non-toxic, non-flammable, breathable materials, then we're going a long way to solving a multitude of problems and reducing embodied energy. So I hope that's of interest, and be happy to take any questions.
Thank you, Tom. That was absolutely superb. I've had rather more contact, even perhaps than I wanted, with BAYS recently, and with a number of organisations who are entirely focused on the metric of carbon emissions in use. It was just so encouraging to know that there is somebody around who's really got their head into this and has assembled so much evidence, Tom. I think that if we're all able to download your presentation and look at it in more detail, we can all start to use that evidence. And in fact, John Preston asks whether you've presented this evidence to the Environmental Audit Committee and or the Public Accounts Committee.
I did actually make a submission to the Environmental Audit Committee, did a review of some of these issues recently, and I did submit evidence, so if it's still there you can find it, but they tended to become rather obsessed with flame retardants, which is an extremely important issue, and one which you know, is a major contributor to bad indoor air quality, and flame retardants are carcinogenic and endocrine disrupting. So it was important that they looked at that. But and for instance, the Irish government has been talking about limiting the use of flame retardants in furniture and so on. But we're only making sort of baby steps on these issues at the moment, and it's quite hard to get this on the agenda. There is also a growing problem with, you know, I think you'll all have heard of greenwash, but we've got a growing problem with what I call well wash. So you've got lots of people coming along talking about healthy buildings as the all-party parliamentary group on healthy buildings and other bodies, but they really tend to gloss over the issues, and very often you find that there are vested interests lying behind these organisations promoting solutions like increased mechanical ventilation as a solution to the problem rather than a holistic approach.
And as I think you pointed out, if mechanical ventilation gets switched off or doesn't work correctly for any reason, I think it was Ian Mordett's study that you quoted. Ian Mordett, I should say, is one of STBA's technical experts. We've got a roster of people who are, you know, right at the top of this industry. And he's an expert on ventilation, and it can easily go wrong, can't it, Tom?
Yeah, well, interestingly, Ian did it was a subcontractor for a study that was done for DEC. I think it was DEC or DEFRA, one of the government bodies. It might have been BAYS as well, I don't know. And it was actually sat on for 2 years, and then eventually, when there was a consultation document about changing the building regulations, which referred to it. And so somebody pointed out they still hadn't published Ian's excellent study on I think they looked at about 70 energy efficient houses and found that the ventilation was completely inadequate. There was quite an interesting article in The Guardian just the other day about how people in Germany reckon that one of the reasons they have lower COVID levels is because everybody opens the windows there. They purge ventilate their houses. Where they even have wonderful German words to describe this that I've forgotten for the moment, but they people in the UK generally don't open their windows as much. I think we're the lowest window opening country in Europe, so that's a big problem as well, because there's nothing you know, people think maybe that they're going to lose lots of energy and heat if they open their windows, but then, you know, natural ventilation to me is the answer, not mechanical ventilation.
Thank you, quite agree. One from Mary Hen, a good SPAB type question, this one, but I think a fairly simple one for you. If you're talking about traditional buildings, how reversible is it to use hempcrete?
Sorry, explain reversible to me. Oh, you mean can you take it out again?
Yes.
Ah, yeah. I got asked about that the other day. Sorry, I'd forgotten. It's a concept that I can't really understand. So, yeah, I guess we could take hempcrete off, but the hempcrete is so similar in many ways to perhaps what would have been there, that the old wattle and daub or lath and plaster or whatever that was there before, that, you know, why would you want to take it out again? I really don't know, but okay. It's a question that we have been asked and we will have to address.
Okay, thank you. I think you're going to love this one from Laura Long. Are there any limitations to using clay as a binder for hempcrete rather than lime in terms of application, i.e. have there been experiments with spraying as opposed to hand casting?
Yes, that's pretty naughty. I saw Laura the other day, so I didn't put her up to this. But the hemp and clay, we're using a clay powder at the moment. It's like kaolin powder, and it's actually surprisingly similar to lime in terms of its chemical consistency, but we just haven't tried it enough yet to see how it works in other situations. I've been largely just using it for casting walls at the moment, so it's still really early days. If there's anyone out there with £100,000 who'd like to help us do some testing, I'd be very pleased to hear from them.
Okay, good question from Joe Atkinson. Can hempcrete be applied? You showed a picture of the Qbot spraying floorboards from underneath. Could hempcrete possibly be applied using that method?
Yeah, well, I mean, it's perfectly possible to spray hempcrete. I mean, Graham Durant is the great genius. He runs a company based in Norfolk called Hemp Lime Spray. And I'd love to see Graham crawling around on some floorboards with his spraying machine, but I'm sure it could be done. And it's definitely worth considering, because in some kinds of houses, that can be a really major source of draft. So it's definitely an interesting idea. I'll mention it to Graham next time I speak to him.
Okay. A question from Alina, which I think begs a much wider question, and it's perhaps for others to answer, but we'd be interested in your opinion, Tom. She says, thanks for the presentation. From your experience, is fabric first still the best approach to advocate?
Yes, that's very interesting, because the fabric thing comes backwards and forwards. I think that when you look at what's being proposed by government through building regulations and zero carbon things and so on, there's a tendency in the industry to think if they stick a solar panel on the roof and an air source heat pump in the back garden, that they can just about meet the zero carbon standards, and therefore they don't have to worry too much about the fabric. There's definitely, you get little sneaky stories about that coming out. So there's a bit of a danger, and I think mainstream house construction industry has already failed miserably from the fabric point of view because of all the work that was done by the failures of that sort of building and the performance gap problem. I mean, the Zero Carbon Hub did some fantastic work on the performance gap, and so the government shut it down, which is indicative of the problems that we've got. So I think that we've still got a major battle on our hands in terms of fabric first. And even this week I was approached about some study which Imperial College are involved in about with the mainstream industry, talking about house building of the future. And they don't seem to want me to talk at their conference, which is usually a good indication that they're doing the wrong thing.
Thank you for that reply, Tom. You mentioned that I'm using my privilege as chair for a moment, you mentioned that the Each Home Counts report had been much maligned. I wasn't aware of that. On what basis was it criticised?
Essentially because it's led to, in a sense, it's a bit unfair to good old Peter Bonfield and the people who did that, because in a sense it's more the implications of what's followed on from it. And I do a lot of work with, when I can, I do what I can to help victims groups like Savali, and they battle with the organisations which are now in charge of retrofit policies, and they are very concerned about things like Trustmark and other things that are being set up, as to how untrustworthy is Trustmark, for instance. So in a sense, it's almost it's kind of unfair on Each Home Counts. It's more what's happened as a result of that, and a failure to really get to grips with what the deep-seated problems, and the fact that there is a major industry out there of white van men, apologies, but it generally is men, whizzing around the country doing all the wrong things. And I think they said the other day they're still going to be allowed to cold call, and under the new government scheme in England, and apply the wrong systems. And I don't think Each Home Counts actually grappled with why that was happening, even though they had evidence of it. So there is a bit of a problem there.
Okay, I'm going to take a question from Francis Volker, which I think may have been originally directed towards for our first presentation. She asks, aerogel is super efficient insulation, much thinner to give the insulation results of any of the fleece or foam products. How does that rate for embodied energy, other pollution factors, and reuse, recycling? Is there any LCA for it?
Yeah, I mean, that they did actually use some sort of aerogel type product in that Kilmainham test that Roseanne Walker did, actually. So there's some interesting data on that. But I think that it's the problem with aerogel is if you stick something in it, you know, if somebody puts a screwdriver through it, then it's not going to be very effective. And it is essentially a product which has been around for a long time. People have been promoting this as a great solution, and yet somehow it never seems to quite get there as something that can be used. I'm not sure. I'd like to know more about it, really.
Nigel, can I answer in there?
Thank you, Peter. Yes, please.
It's Peter. Sorry, my video's turned off. I don't know. Anyway, yeah, I didn't mention, but we're part of an international study with the Fraunhofer Institute of Building Physics in Germany, where the German government gave us a wing of a early 18th century monastery in Benedict Beuern, and we've converted 18 rooms into and put in different products. We're using aerogel mixed with a lime render on the external of one of the walls, and it is performing incredibly well. We've also used the aerogel blanket on window reveals where you're limited for space. But at the moment we are trying to work with the company, I think it's called CADOT, C-A-D-O-T. It's an American company, but they're actually manufacturing it in Germany. And we're working with them looking at pollutants and recyclability, et cetera, et cetera.
Thanks very much, Peter, for that. I think we'll now move on to our next presentation. Very pleased to be able to welcome Brian Murphy to our conference this year. Brian Speckman Murphy, as he sometimes calls himself. He was behind GreenSpec, which is one of the most useful resources if you're looking at new build in particular. And for refurbishment, you can use it to compare embodied energy and other environmental impacts of materials very easily and simply. He's also developing the green building calculator. He is a specification specialist. This is on the way, and I'm sure he'll tell us a lot more about it. So, Brian, welcome. And are you in a position to screen share now? Or have we lost you? There you go.
Should be there.
That's it.
Can you see the slides?
We can see a lot of them.
Okay, that's what I needed you to see. Okay, let's go into the show. Thank you. Thanks very much. Yeah, so Green Building Calculator, it's come about because we had this long lull, and I thought I'd do something interesting instead of sitting around doing nothing. Oh, I've got to move this out of the way. I can't see my own screen. Okay, I don't know whether I'm going to, okay, carrying on. Okay, so today, and there was this sort of cryptic, I can't move forwards, cryptic title, target U values, overheating, green cost plan, value engineering, minus cost cutting, BIM BOM and BIM BOC, and which are bills of material, bills of quantity, embodied energy, embodied carbon, sequestered carbon, life cycle assessment equals GBC. So the intention is that I'm building a big, powerful calculator that can do a lot of things that a lot of us need now to do and will help us to do our normal job. So Green Building Calculator, not UK Green Building Council. So first version was published in June. It's available on Green Building Calculator website. There will be a video shortly, and the files are already available and at incredibly low cost. So this presentation and a longer version of it will be available on Green Building Encyclopedia website and eventually on Green Building Calculator website. So today I'm showing you version 1 plus some of the developments that are going on in version 2. Version 2 hasn't yet been published, probably end of October. So you're seeing 84 out of 227 slides. No one's going to see all of them, but anyway, they're there for those who can persevere. And we've got loads of time on our hands now, so. Right, so why did I start doing it? Because I want clients to be able to get what they've asked for. I want quality surveyors, not quantity surveyors, who do value engineering, not cost cutting, and look at whole life cost, not just cheap. Manufacturers, I want more, better data, and I also want multifunctional products. I want environmental assessors to be able to guide designers with some facts, and I want building designers to do more analysis themselves than I see happening most of the time. Tenderers, I want them to have the chance to do a proper job, price a proper job, and aim for no claims for extras. That isn't going to happen because of the way industry is working at the moment. And I want BIM to do all the things it claims to be able to do in all of the advertising. And I want advisory bodies to be able to give more robust guidance data. So I want more evidence-based design. I want competent as was intended. So manufacturers are kind of developing new products to do certain things, and then we use them in the wrong places. So I need that kind of squashed as quickly as possible. I'm just going to try and move this. Can't see the screen myself. So data sets, equations, calculators, and apps. Again, I can't move forwards. Right, so data's okay as long as you've got lots of it. It's not much good on its own. You need a lot of it. It needs to be consistent, all in one place, all in one spreadsheet. Open databases if you can get hold of them, and data sets do not tell the whole story. Behind the LCAs, there are reports which identify all sorts of other issues. I'd like the idea of donating data, which I noticed on Peter's slides earlier. Equations are essential. Equations can interrogate the data, and then calculators save time, consistently apply joined up equations and data sets. We need them to be ready-made, waiting to be used to speed up the process. We can have built templates where a lot of information has already been developed for you. to be able to accommodate choices and changes and bring instantaneous results. When we do a calculation, if we change one material or a thickness, we need to see the results all the way through all the calculations. We need to interrogate many issues at the same time, allow comparisons of different scenarios, to do proper value engineering in its original meaning, not just cost cutting as is practiced in the UK. And it could become an educational guide and a problem avoider. We could enable and empower individuals if we've got some really good calculators. And of course, CAD BIM app calculator, if we can have it, saves time populating the input cells in the calculator, and allow a two-way flow of information from the calculator to built models and template wall elements, etc. So I want, but I'm reminded that actually if you want something to change, you've got to do it yourself. So I decided to get on with it. So I've got 20 years of idle information, collecting thousands of product information, spreadsheets, specifications. I've even got 892 elemental assemblies from Green Spec Studio, elemental assemblies to passive house energy standard, competent construction assemblies that have been assessed and attested, and potentially a specification generator off the back of that. And then more and more calculators and equations. So the whole building calculators I've been developing in universities for students or for myself or for research project or for practice projects, including things like developing the ICE database into an Excel so that you can do practical comparisons because there's so many different formats. Whole building calculators on embodied energy, embodied carbon, sequestered carbon, energy and carbon in use. The waste cost light calculator, which I produced to show BRE how to do waste calculators. And then PSI values, which I've done for manufacturers' calculations. So version 1 was published June 2020. And that took about 440 hours. I've done another 395 hours developing version 2, and I'm hoping by the end of October I'll be able to launch version 2. I've got 21 versions planned, 24 months possible development time. And this all comes from a desire to drive environmental improvement. So bio-based construction through the CAPM project that we worked on, European funded project, which was all about LCA. Plastic avoidance, which, you know, both of these items have been mentioned by Tom and Peter already. Changing streams is a project, a European funded project, which is looking, no, it's not. CHARM is a European funded project, and Changing Streams is a plastic avoidance campaign where they're doing more research and gathering information together. And circular economy about recycled content, reclaim and reuse, reclaim materials with product passports, the BAM project, which is a Horizon 2020. So a kind of executive summary of the calculator. There's a lot of parts to this. I'm not going to dwell on this at this stage because I want to show you the calculator, but it just gives you an idea of what we're trying to engage with by bringing a lot of different calculators into one place. So all of these 5 parts are already stitched together very robustly and interact with each other so that every time you add information in the early stages of the calculator, it has an impact further on in the calculator somewhere else. And so once you've got every bit of data in, if you then change something, instantaneously, the calculations run all the way through the 5 modules to give you up-to-date data in all areas. So I'm developing it at the moment, and the parts, the progress is in light green, the dark green, the non-domestic part is only partially developed. It was originally developed for new build for the university students. It's gradually kind of evolving. So in order for the version 2, which has got a high degree of retrofit ambition built into it, is having some parts of version 1 updated. Again, I won't dwell on these too much at this stage. and some additional modules being added into it so that we can look at terrace, community scale projects, interior furniture, MEP services, landscape, so that we can do a whole bill of quantities for a building that's being refurbished or a new build. Some additional items for overheating, condensation checks, because if we don't do those as well at this early stage, we might as well forget it. We're going to get buildings wrong. And of course, the condensation check using BS 5250 is a very, very basic one. But all I'm trying to do here is identify what we shouldn't do. Rather than tell you this is a good piece of construction, we can identify the ones which are wrong. Then we've got the embodied energy, embodied carbon, and life cycle assessment calculations, including sequestered carbon if you're using timber. The life cycle assessment part, the EPD, all built in, already started, and I'll show you a bit more of that later. And a bill of materials, bill of products, bill of quantities, bill of labour, bill of costs, and then you can start doing cost planning. You can have a tender schedule, and you could probably do some proper value engineering, not just cost cutting. And then we've got some additional information on fuel cost and fuel cost in use. So that is kind of developing. And that's what the kind of whole thing looks like as it is today. It's not complete, and it won't be until the end of the month. And there may be one or two things which don't quite make it to version 2 and might get dropped into version 3. So I wanted to kind of get, and the current development, the pale green is already well underway. The dark green is possibly not going to make it. Decrement delay and condensation check might end up in version 3. LCA calculator and miles, material miles, I'd like to get that in. I've got the LCA bit in, the material miles bit might be a bit more complicated, so it might end up in version 3. MEP services, well underway. And then the other bits of the proposed development, the pale green stuff I've brought forwards into version 3, and the remainder is kind of sitting there waiting to be developed. So, you know, getting all the way down to interiors, plastic free, waste calculator, waste cost, circular economy, reclaim and reuse, all those things will come. And a self-build interface, because the self-builders don't always understand our jargon and our language. So version 3, planning to put in elemental assemblies. I've got 892 elemental assemblies, but in order to do that, I need to kind of subdivide the building up into component parts to be able to kind of make sure that we use materials in the right places, because there are big problems. So this is how I'm kind of breaking up building elements into sub-elements and to component parts. And I'm also very well aware of the problem that Tom brought up. In fact, Tom and Peter both brought it up, that the use of thermal insulation materials in the wrong places is fundamentally a problem that we really have to get to understand. I did this part of the product environmental footprinting PEF European community project to kind of start to identify those materials that should and shouldn't be used in different places. So once I've got that piece sorted out, I then need to drive the Excel spreadsheet to stop you putting the wrong materials in the wrong places. So I'm also doing elemental assemblies, 892 ready-made. Users' bespoke assemblies will invite users to donate their information. Manufacturers' competent system assemblies, when they are at least Agremont certified, if not European technical approval and other things. And we want all of this stuff to be in lookup tables so you can pick and choose materials, but you can only pick those that are competent in the application. And at the bottom of the process, there'll be a specification generator, because I've got the stuff in spreadsheets. So there's a big hierarchy of 892 elemental assemblies in hierarchical order. Every one of those elemental assemblies has got a spreadsheet listing like this with the full specification, generic prescriptive specs and performance specs to be developed. The elemental assembly includes all of the component parts, and there's also a critique in here which tells you whether this is a high thermal, potentially air leaky, high embodied energy, things like that, just brought to your attention so you can make some decisions about whether you want to use this assembly or whether you want to go another route. So future of development, I'm just going to pop in a few extra things that we've been thinking about. Service design module, lighting design module, biodiversity inclusion calculator or something like that. Local climate appropriate, I think this is probably quite important and needs to come earlier. It's about using the right building technologies in the right climates. You know, Europe, Middle Europe and England, UK, Wales, Ireland have got some seriously different climates, and they do need to be addressed in a more robust way. There's a guy who's kind of really keen to start talking vernacular. I'm interested in local and a green building price book, which we talked about 20 years ago, but never happened. I've been talking to the original guy that proposed it and thinking about how we can kind of make it happen again. And then we can have some proper value engineering stuff going on. So then bespoke development opportunities. Now this is a kind of an idea that's been kind of prompted about actually understanding the real impact of upgrade measures. It might be changing windows to double glazed or triple glazed windows, or it might be upgrading the glazing. So we need to have lots of embodied and energy performance of glass spacers, gases, low E and SC coatings, frame profile, frame materials, weight, trickle vents, all those things. So we need the embodied energy, the embodied carbon, the sequestered carbon. And my calculator can do all of this stuff already. What I need to add into it is energy saving before and after, carbon saving before and after. That's an easy calculation to do. And then the cost of the upgrade measure, the in-use energy cost saving before and after, the financial comparisons. What we don't want to be doing is looking at temporary and short life. We need to be looking at normal, which is 50 or 60, depending on whether you're England or Europe, or America, 75, I think was mentioned, or long-term. The value for money, so cost payback periods is a relatively easy thing to add in. But we mustn't be looking at cost payback periods. We need to be looking at carbon back periods so that we start to do proper value engineering on energy, carbon, etc. But don't forget when you do these kinds of comparisons that you have to look at the other features, benefits and considerations. Thermal comfort comes into mind. If we think that going to triple glazing is bad environmentally in terms of embodied energy, embodied carbon, etc. But we must also think about thermal comfort. For example, with Passive House, thermal comfort was the primary aim. And if you start dropping to double glazing, you're not going to achieve your thermal comfort levels. And there's a potential for more condensation risk, vapor, open construction, materials. We need to think about those too. Plastic content. You know, we've got to think about plastic avoidance, recycled content if necessary, and the big fire life risks associated with plastic materials, which have been mentioned already. High recycled content may lead to bad choices. RAP did a great job of encouraging us to use higher recycled content, and we ended up changing materials and properties and ending up with materials, buildings that probably didn't work very well. So I did a quick analysis. This is really rough and ready, gut instinct stuff about using single, upgrading to double, you know, using secondary glazing. I'm just going to try and turn this thing off because it's getting in my way. Okay, secondary glazing, double glazing, replacing with double glaze, replacing with triple glaze. So all of the kind of environmental impacts, we already do these in the calculator. We probably just need to add in a little module that does carbon saved in use. We could add in payback period. We can add in carbon in the waste, and we can do carbon back period. So all of that stuff can be done. So we just need to convert all of these pluses and minuses into real numbers. We've got evidence-based design and evidence-based specification. and so we can have better, more robust information available to consumers. And this is the sort of thing that we might have hidden behind some advice. So we've got the energy performance, the U values, the energy saving, the cost savings, the carbon savings, embodied energy, embodied carbon, and sequestered carbon, all that data behind the advice that we can give. It doesn't take much. We've just added in the 6th module, which is the waste, which I'm planning to do in version 11, but I might need to pull it forwards. And then add in some additional items, which we've talked about already, to kind of address this stuff. And a lot of information based on the waste cost light calculator, which I produced over a weekend and told BRE, go ahead and do this, gave it to them for free. It took them 3 years, but they got there in the end and they produced an equivalent tool, by which time the QS has left the building. So 21 versions, 24 months of development. Early versions generate early sales, which mean a little bit of time and money, so I can keep on developing it. Users to guide, so we'll set up a kind of steering group to make sure that we're kind of prioritizing all the stuff that needs to be done soonest. Early consultancy work on house types, competition entries, compare element upgrade measures, all of those things can be done to help parts of it to be developed soonest. So now I'm going to look at some screenshots. There's a whole bundle of instructions. I'm going to try and turn them all into pop-up menu, and on all of the cells where the activity needs to be carried out. There's color coding of the cells so that you know what to do. If it's green, I'm looking for the users to put information in. If it's pale green, pale blue, then the calculation has been done for you, but you can overwrite it if you wish to. If it's dark blue, then it's permanent, it's sorted out, the calculation's been done for you. And occasionally there's some pink cells, which are drop-down menus. And in the BIM world, a lot of this information will either come from bills of materials or from the model itself. So that's where we'll be heading in due course. And it's just a case of, there's a lot of spreadsheets, there's a lot of worksheets, and you just got to go in and populate some of the cells. Sometimes there's some drop-down menus. So the green ones, so we've added the terraces for the retrofit. We can add the numbers of terraces. You can choose whether the building is in the middle of the terrace, at the end of the terrace, and then it will do some more calculations for you. You can say how many hours the building's in occupation, what temperatures you're aiming for, and you can tweak a few other bits of information in the tables. A schedule of accommodation if you need to go closer than building level, so you can look at every room, every floor, and the size of the rooms, the temperatures of the rooms, the heights of the ceilings, all of those things, and then put a yes in the right cell, and off you go. The calculation starts generating the information you need to know. And for retrofit, we've got roofs, dormers, parapets, overhangs, gable walls, parapets. So we've got some extra calculations that go in both for U values, but also for embodied energy, embodied carbon, LCA, etc. And again, you interact with it, put some information into the right cells. Other geometry roofs, because inevitably somebody's going to do something fanciful. So we've got that calculator. It's not been developed. I've set that aside for now so that the Zaha Hadids can kind of do really complex stuff later on. I'm not dealing with that straight off. Room by room heat loss calculators, so that you can engage with how much energy do I need to heat this building, these rooms, what radiator sizes, what underfloor heating components do I need. You can put in a boiler size, and then you can work out whether you need more insulation in any of the walls. Then a form factor calculation, so that we can start to engage with the shape of the roof, whether or not the building has rear extensions, whether there are weather porches, conservatories, sun space, bay windows, oriel windows, dormer roofs, all the sorts of things that you might start adding to existing terraces in order to kind of deal with the old building stock. Just going to go back one here. And the form factor encourages you to use better U values than the building regs. In terraces, it probably will permit you to use less insulation. And there's a kind of a general rule of thumb about thermal insulation using mineral wool and thicknesses in the bottom half or in the bottom quarter of the table. If you choose a different thermal insulation material and pop it into the cell at the bottom, it will then tell you how thick those thermal insulation needs to be for the different form factor values. Here we actually go into the scope of work of the building. You're deciding which bits of the building do you have? Have you got basements? Do you have basement floors, walls? Do you have a swimming pool? Do you have ground floor over basement, ground floor over voids, etc., etc., etc.? This was the early version. The later version has significantly larger number of components. On the left-hand side, it's building envelope components. On the right-hand side, it's all of the rest of the stuff, inside and outside, landscape, services, furniture, etc. So you just go in, put a yes or a no from a drop-down menu, and I've highlighted a few of the things that are relevant to historic building fabric, so brick footings, sleeper walls, underpinning, which is probably going to be necessary in some situations, and some other components there, structural frames. If you're doing timber post and beam, then we can engage with that as well. And then the bespoke set, the 892 ready-made assemblies, they'll be available to engage through this in a later version, in version 3 and 4. Non-U value envelope components, so basement external well, so there's building fabric involved in those, basement internal walls, partitions, shafts, compartmentation. Then we've got a whole chunk on eaves, parapet, party wall. So going into a bit more detail, and kind of cherry picking all of the parts of buildings. And I've done a few project specs recently where I've had to add in a few additional elements. So as I keep thinking of them, I kind of place them in the calculator and come back and add them in more detail further on. And then if you're interested, external works, and if you want, you know, bill of quantities for the whole building, then you're going to have your external works, your furniture, your MEP services. I've subdivided the MEP services in domestic and non-domestic so that we can engage with domestic more rapidly. And these could be just an item from a supplier or an installer, or it could be broken down into much more detail, which the calculator will do in due course. And then for every one of those elements that I've described so far, the calculator goes into more detail and starts working out areas and volumes. Occasionally there's a few more bits of information that are still required. Building outside the envelope, foundations, structural frames, secondary elements, including things like staircases, because in many cases we'll be ripping out staircases and putting whole new staircases in new positions with new geometries. Furniture, particularly attic roof furniture, other furniture, sanitary wares, kitchens, bathrooms, landscape, and domestic services and non-domestic, all. And if we have things like windows which come in a multitude of sizes, the calculator can deal with those. We can then, over here, we've got the opportunity to either use the information from this sheet, or you can choose by dropping the menu and picking out multiple, as has been done here. It will then pick up the calculations from the previous table. And then choosing your U values, whether you're using regulations or whether you're using other design standards. We've got all of them patterned out, all laid out here. So we've got elements down here. Elements of the building are down here. We've got, oh, backwards, go back one. So we've got all of the regulations, building regs, England, probably Wales, Scotland, Northern Ireland, other countries, fees, stuff, past 2035, other design standards. So all the design standards come here. So ACB carbon, Passive House Institute, Minigi, Zero Carbon Hub, LETI, RBA Carbon Challenge, National Building, Green Building Councils, and other stuff, Transport for London, BREEAM, and Code for Sustainable Homes, which are kind of relegated to that over there because I'm not that impressed. Although the U values for BREEAM seem to be quite good here, which is good. all color-coded in a single, so you can see which regulations do well, which ones don't do very well. And also down here, we've got other things like glazing percentages, orientation, form factor. And so all of that information is there. So you can choose a standard and you can choose which letter of the columns do you put in here. AB, for example, comes out at ACB, etc. And moving on, insulation, all the different insulation materials with their K values and all of the U values on the right-hand side. So loads of different materials, different formats of thermal insulation. And so we go into K values, worst, best, and average. The average is used in the calculation. The U values that you've chosen from the AB letter from the column in the previous sheet then applies itself in here. It then recalculates all of your K thicknesses of the thermal insulation to suit the K values of those materials. Some materials I've advised not to use, like asbestos cement and ceramic fibers, and some information I still don't have the data, but no doubt I'll get that as we progress. And it kind of goes all the way through. I've also got a decrement delay calculation for overheating, summer overheating. That hasn't been developed yet, but it's sitting there waiting to be done. And so then we've got U value calculations for 12 elements of the building. Next, that goes up to 24 of 39 in total. That will all be in version 2. So it's a case of putting in here which element of the building, which component of the element are you including? So we've got decoration.
My apologies. I couldn't hear what you said.
Go away. Just turning all the friends off. Okay, so so here we have a whole bundle of component parts where we choose the material. At the moment, we have to populate these cells manually, but in the version 2, I hope that this will be populated dynamically. You choose one material here, and all these cells will populate themselves automatically. In due course, the product information will allow me to choose the product name here, and it will populate all of the cells across. Having chosen your thicknesses in here, it will tell you whether you've passed your U value target or not, and you can then tweak your thicknesses until you've got all of that stuff sorted out. We've got a little calculation going on here, whether this is to do with thermal bridging, and that's the size of how much of the space is occupied by framing and how much is occupied by insulation or air or whatever. So that allows you to do calculations for thermal bridging in timber wall construction, for example. Moving on, there was a little calculator, there still is a little calculator where we could just look at insulation costs and compare insulation and glazing so that you can actually start to do some value engineering with your client, saying spend a bit more money on thermal insulation and spend a lot more money on glazing to get your U values improved. I've added in the condensation check, which is not complete, it's in development. I've added in the overheating calculation for decrement delay calculation, but that's not complete. I've added in the bill of materials. Now, one of the important things about the bill of materials is we need to know about the refurb action. So we've got the component part, we've got what it's made of, and we've got the calculations going on here where you add in the prices, but you actually need to give the guidance to the contractor. Are you using the existing? Are you preparing? Are you overcoating? Are you using the existing unchanged? Are you removing, reapplying? Are you removing, reworking and reapplying? Are you using the existing unchanged? So these are from a drop-down menu, which has already been developed. It will no doubt keep on developing. Then the contractor could price their labor rates and their material rates, and you've got a bill of quantities so that you can then start to look at things. And comparing a full bill of materials, quantities and cost with the RICS's kind of standard arrangement is detailed elemental cost analysis, where 5 or 6 of these elements would be lumped together in one single calculation. There's no way that they can be getting this accurate enough, and there's no way that we can be relying on it. And the way the industry's gone, where people are beginning to question whether SPONS is good enough and whether the way we tender for stuff is good enough, we've really got to move on and do better. So the embodied energy, embodied carbon, sequestered carbon calculation is already built in. It's just a case of you choose the material from a drop-down list, and then all of the cells choose the material in these cells, and all of these cells populate and calculate. And then up here, we get the whole building calculation all in one go. So you've got embodied energy, embodied carbon, sequestered carbon, is it made of timber, sequestered carbon, and total carbon, all done for you. So then we go on to the life cycle assessment part, and using data from some of the information that was presented earlier from Callum Hill and Andrew Norton, and using the BSEN 15804 version 12, I've added in the priority areas and highlighted those things, but the calculator will allow us to populate all of the cells. So this is based on that one element that we've been looking at. And we need to prioritize. There's going to be the latest versions of EN 15804 are asking for significantly larger amounts of information, subdivision of the LCA EPD data, to the point where an awful lot of it's becoming less and less relevant. And the ones that are important are the global warming potential, ozone depletion potential, because that still remains an issue despite legislation driving out ozone depleting chemicals. So, you know, we're getting there. Resistances, which you're all familiar with from the various standards, conductivities of materials, properties of products. So this is where we need the manufacturer to provide us with information. Both manufacturer and suppliers are offering information and providing some of it for us. We just need to put more and more information into this. More shared data is needed. I've got a secondary element calculator so that we can start to work out U values of glazing, U values of frame, U values of window. So all of that's already developing. And here we've got a whole bundle of windows, doors, etc., using different materials, different glazing fenestration configurations, but also double, triple glazed units and single glazed units here with and without gas, with and without coatings. So we can then start to cherry pick various combinations of those, start to make decisions.
Brian, this is your 2-minute warning if there's anything you really want to get across in the last couple of minutes.
Thank you very much. I'm going to whiz through the rest. So we've got elemental summaries for all of the stuff. This is where you bring all of the energy together and work out the energy consumption of the whole building, energy consumption of the component of the groups, so elements, windows, doors, floors, roofs, etc., subgroups, so that you can begin to see, oh, the windows are wasting so much energy. We've got to kind of focus on them and put some more money into the windows. We're going to look at fuel carbon factors. We've got more and more drop-down menus in order to engage with the refurbishment part, more manufacturers' data, where we're going to give them really intelligent spreadsheets so that they can populate them more readily. And for anyone who needs any encouragement, 3 months after launch, we've got 3 awards, the Green Apple Environment Award, and we've got 2 shortlistings for the Construction Computing Awards. So those, hopefully, fingers crossed, we might do well. But I think for the SIBSI calculation, I suspect they'll want to interrogate the thing in an awful lot more detail, and then we'll be able to kind of work out the where the nooks and crannies need sorting out. And that's me done. There's an awful lot of information out there. So yeah, please ask some questions.
Brian, that's absolutely fantastic. I think this is going to be a tremendous help to all of us. There's various questions that have been raised, but we'll take those at our session at 12:15.
Okay.
I'm going to now introduce Sophia Haywood, who is the Director of Public Affairs for Liquid Gas UK. And it may be unusual in a sense for STBA and SPAB to have a trade association at the conference in that sense. But I've been working with Sophia on a group looking at the minimum energy efficiency standards for the private rented sector, convened by Joe Lugg of the National Trust. And in particular, we're very interested in what she's got to say about bio-LPG as one of the strategies for dealing with off-grid properties. So over to you, Sophia.
Thanks, Nigel. Really pleased to be here. So thank you for inviting me. Let me just share my screen. Okie dokies. Hopefully that's all working okay. Yep. So yeah, thanks again for inviting me. Really pleased to be here today to talk about the energy side of things, and in that, in particular around the role for LPG and bio-LPG. Really exciting area, and I think that there's a lot of opportunity for off-grid decarbonisation moving forward. I think the one thing is clear, and it's been a theme throughout all the presentations, is that there's no one size fits all approach to anything, whether it's the decarbonisation of the energy fuel itself, whether it's the building, all different aspects. There's not a one size fits all model that is going to work. So firstly, just a little bit about us. So we're the trade association for the LPG and bio-LPG industry in the UK. We cover 99% of the total LPG distributed in the UK. So that's virtually, as you say, pretty authoritative voice on the LPG supply side of things. But we also have members from the equipment suppliers, service providers, installers, different sectors that use LPG. So for example, we work really closely with the likes of the National Caravan Council and the BH and HPA, onto the catering side of things, a number of different sectors that use and rely on LPG in off-grid areas. We used to be called UK LPG, and last year we rebranded to Liquid Gas UK, and we did this along with a vision that we launched, which was really exciting. And essentially it's called the 2040 vision. I'll go on to talk about it a little bit more, but in a nutshell, it's all about our transition towards bio-LPG and what the industry wants to achieve over the next 20 years, which isn't a very long time, especially when you start looking at some of the targets that UK and devolved nations are coming out with for decarbonising off-gas grid buildings. Right. Gone slightly ahead here. So just quickly, just a little bit about the LPG industry. We launched a census in May this year, and it was the first time really that we'd done an in-depth survey of the industry. So it was really interesting. A couple of kind of key facts there about the sector, but what I'd like to highlight is that industry is preparing for the future. There's a huge amount of investment going on across the sector. The one thing is the 600 million that's going to be invested in the sector over the next 5 years. There's going to be 150 million being invested in the next 12 months, across a wide range of areas, from the transition to bio-LPG through to assets and infrastructure, and general logistics as well. On bio-LPG itself, there's 106 million currently being invested into bio-LPG, separate from that figure. So industry is putting their money where their mouth is. This is something that we take really seriously, and industry is really keen to get moving on the transition to bio-LPG. But we'll go on to talk about what that looks like as we move forward. So a little bit on why LPG in the first place. So LPG is the lowest carbon conventional fuel source that you can use off the gas grid. So we're looking, when you compare with the likes of oil and coal, you're looking at up to 20% less carbon emissions than oil, 33% less than coal. Clean burning, it has the inherent benefits that a clean gas brings. Very low NOx, SOx, very low levels of particulate matter. It's why we're seeing increasing use of LPG in taxi retrofit, for example, in city centres and in urban areas that are looking to improve air quality, because you get that immediate benefit, complementing electrified solutions. It's versatile, and I think LPG is probably one of the most versatile energy sources in the world. You know, it's used from anything from actually powering a rocket at the moment through to the Olympic torch to all the other uses across a vast range of sectors and industries. You know, it's used across the UK. We have members spanning, you know, UK focus and some that are just involved in each of the devolved nations. But perhaps one of the most exciting things around our transition to bio-LPG and the role for LPG today is that all the infrastructure that you currently have with LPG or you might look to install with LPG is ready for the future because it can take bio-LPG at 100% blend. So some of the limitations you may have potentially seen with use of biofuels where, you know, for example, with bio-oil or a bio-kerosene, you're likely to have to change your infrastructure, change your tank after a 30% blend because it will corrode it. You don't get that with bio-LPG. And also, it has a role on its own, but it's the perfect partner for hybrid solutions as well. So completely complements, you know, heat pump systems. Works really well, and you're going to get the best carbon savings with an LPG to bio-LPG hybrid heat pump than you are with an oil-based hybrid system. So a little bit on the 2040 vision. So as I said, we launched this last year. Industry's incredibly keen to demonstrate its role in the UK's net zero future, and that's partly my role in government affairs, is to work with policymakers across the UK and highlight the role for LPG bio-LPG. So I'll go on to talk about this in a little bit more detail, but in a nutshell, bio-LPG is made from a diverse mix of biological feedstocks and processes. It's often a co-product of those processes, so it's almost like a two for the price of one mentality. I like to simmer it down to that kind of level. Up to 90% carbon emissions reduction when using bio-LPG, depending on that feedstock and that process. Obviously, it fluctuates depending on the feedstock that you use, but I can go on to show this, illustrate this a little bit better on the next slide. As I said, it's a drop-in fuel, so you know all the infrastructure is ready for the future. So it means the supply chain's there. It's a very well-established supply chain. People are familiar with the technology. You know, this means you don't have to retrofit your property to continue to use bio-LPG, and you've got very low consumer disruption, as well as obviously the immediate and expedient heat or hot water. So bio-LPG is available on the UK market. So some of our members sell bio-LPG in the UK, and it is available kind of globally, but mostly in European markets, and particularly the UK is one of those focus areas with perhaps one of the more ambitious net zero targets and what we're looking to do with off-grid areas. So just on bio-LPG feedstocks and processes, there's a little bit of a table, hopefully you can see there, it might be being covered by the chat box. I'll just move mine. So you can see the range of different feedstocks and processes that you use to get bio-LPG. I'm not going to go into a huge amount of detail on this now because I'm only going to be giving a short presentation, but happy to answer any particular questions you might have on this and share a lot of research that has been done on this. So, one of the most, where we get most of the bio-LPG from today is from HVO processing. So where you're processing vegetable oils, potentially use cooking oil to create biofuels, and as part of that process you get bio-LPG as a co-product. Similar to how you get LPG today, in a lot of these processes you can't not make LPG or bio-LPG, which is a pain for them but great for us because it means that we have access to this kind of fuel. Other technologies which definitely have a role to play in the UK moving forward are things such as gasification and also isobutene production. Now, when it comes to bioenergy, and I think this falls across the whole bioenergy spectrum, I think it's really important to take a holistic approach to this. Different nations are going to be using different feedstocks, for example, more than others. Different feedstocks will be used by something else, and therefore, for example, in Wales, we might be focusing on one particular type of feedstock, forestry residues or sawmill residues as one example. So I think it's really important when you look at things like this that you take a step back and you think about how it's all going to intertwine in this bigger picture for bioenergy in the UK moving forward. So Liquid Gas UK members are investing in imported and localized production. This is something I'm personally really interested in, and I think there's a huge amount of opportunity ahead. Things like you might have seen in the news yesterday around the Jet Zero Council, or the day before, tackling transport as one of the biggest and hardest to decarbonise sectors with creating biofuels and bioaviation fuel. At the same time, you can get bio-LPG as that co-product and tackle the two biggest areas that we need to decarbonise in the run-up to net zero. So a huge amount of opportunity. Again, happy to answer any questions or have a follow-up conversation on this. So off-grid homes, really, when we're talking about decarbonising off-grid homes, we're talking about the 2 million rural off-grid homes for our market, and the majority of those use heating oil, and around 200,000 use coal. But heating oil is generally the one that we're talking about when we're looking to tackle decarbonisation of these areas. We need to have different solutions for different types of buildings. You can't have a one-size-fits-all approach or model, but you can take lessons and overarching themes when you're looking at decarbonising these types of buildings. We had some research done last year that showed taking a mixed approach to off-grid homes. So this is a mix of heat pumps, a mix of LPG, bio-LPG and biomass in certain instances as well, could save the UK over £7 billion in levelised cost analysis in the run up to 2050 and still meet the net zero targets that we need to meet. So, it's not just about actually consumer preference and being able to choose what solution works for your home. There's also a financial argument that you're going to save a lot more money in off-grid areas by taking this approach. So what we need to see is a long-term policy framework that enables consumers to make these choices, have from a mix of low carbon solutions, and ultimately make sustainable choices that work for them. What we don't want to see is potentially policy coming out that could have a lot of backlash. A lot of rural MPs potentially got some very unhappy constituents complaining about this, and then you end up back at square one and we don't make any progress in the interim in off-grid areas, and that's something that we don't want to see. So I think that's incredibly important. And I'm probably preaching to the converted really, but I don't think necessarily policymakers fully understand some of this about why you can't take a one-size-fits-all approach. Heat pumps, for example, are going to work really well for some buildings, but for some buildings it's just not going to be feasible, or it just might not be cost effective, and you're going to need to have a mix of other solutions. You've got to take that whole house approach. You've got to look at how that household or in a business circumstance actually uses energy, what they're using it for, how they're using it. I think COVID is this one example of, my bills are going to be a lot higher this winter because I'm going to be working at home full time, and I'm definitely not going to just be having the heating on 5 a.m. to 8 a.m. and then in the evening I'm going to want it on during the day. So all these types of uses need to be taken into account. You've then obviously got the geographical and kind of settlement attributes as to where properties are based, and whether it's the strength of the electricity network, or you're looking at varying different factors that come into play here. You've got to take it into account. It's not just the carcass of a building, it's all these other parts as well. You then look at the people who live there. What is the socioeconomic factors there? Not everyone is going to be able to afford to retrofit their homes to a certain level. You're going to have to take a holistic approach. And I think with the Green Homes Grant, I'm sure you will have all heard about this, there's some real big plugs from government on this, and I think it's because people are generally quite reluctant to undergo major retrofit of their home. Potentially, probably hasn't helped that a lot of people also did a lot of housework and house upgrading during lockdown, which I'm sure we all had lots of trips to B&Q to get a fresh coat of paint. Character and heritage is incredibly important, and a huge part of what this group do. And I know, working with people like the National Trust and Historic Housing, among others, this is incredibly important. And I know the Environmental Audit Committee has taken a leaf out of that book. And then lastly, but importantly, based on all of those factors, cost does play a key role. We do have to think about how people are going to afford a transition to net zero, whether that be with energy costs or whether it be with retrofit costs. And sometimes having a limited amount of grant funding isn't really going to cut it for a long-term transition to how we begin to decarbonise these buildings. In terms of just to reflect perhaps on some of the public policy landscape at the moment, and this is probably more of my bread and butter, we've got the Green Homes Grant, which, excitingly now hybrid heat pump systems are included. The grant funding won't go towards the boiler part, but it will go towards the heat pump. I think this is a good step in the right direction, bearing in mind that the proposed Clean Heat Grant were very reluctant to support hybrid systems. So I'm hoping that this will mean a bit of a U-turn on that stance, because I think that we should be encouraging people to install hybrid systems where appropriate. Not fixing the EPC methodology is obviously a massive missed opportunity in public policy. I'm sure you will have all seen the recent announcement from government with their EPC action plan, which doesn't really say very much. I know there's good intentions and good signs with moving towards a more how energy is actually used in that whole house approach, but the methodology is causing major trouble in terms of off-grid decarbonisation when you're incentivized to use heating oil to get a better EPC. So when you have things like the private rented sector regulations in place, there's an inherent advantage of sticking with what you have rather than maybe moving towards something low carbon, and that's something that we often get approached by heating oil users or landlords about, and yeah, it seems insane that it is still yet to be fixed, but that's something that we're pushing on really hard, and I know with Nigel and the group it's something that we're spending a lot of time on. The Environmental Audit Committee is having an inquiry into this at the moment, and I think that there's really good opportunity there for the committee to come out with some strong statements to get BASE to actually get around to dealing with this rather than trying to stick their head in the sand at the moment. And that kind of comes back into the whole decarbonisation policy agenda, which is very reliant on EPCs. So until that's fixed, it's going to be really difficult for government to really make any headway in this area. And soon it will stop being an off-grid issue. At the moment it's very much an off-grid. If you're not using natural gas, this is the problem. But as we move towards wider use of electrification and heat, for homes that are on the gas grid, and also look at a potential transition to hydrogen, theoretically, if we all switched over to hydrogen overnight, it would be more expensive and we'd all get a worse EPC the next day, which, when nothing has really happened to your home, it doesn't really seem to make much sense to have a process like that. So, but in terms of opportunity, the heat and building strategy is still room for influence. It's not kind of set in stone, and I would really encourage everybody on this call and on the conference and the panelists to feed as much of your knowledge into BASE as possible. I'm very worried that an off-grid policy might come out that isn't really going to work in practice, and I think we all want to see something that's going to work in practice at the end of the day. I think that draws me to a close, and I'm conscious of time. But no, please feel free to contact me if you have any specific questions, and I'm happy to take questions obviously in the Q&A session as well. So thank you for having me. I hope people have enjoyed it.
Thank you, Sophia. That was very informative indeed. First question, I think I'm going to put to Brian, as we didn't have a chance to take any after you spoke. Joe Atkinson asks, do the U value calculations account for thermal bridging?
Yeah, so my take on it is that in the elemental assembly, there's a calculation where if you've got timber frame construction or metal frame construction, then you account for the volume of the framing and the volume of the insulation or the air gap in the elemental assembly. When it comes to the abutments between elements, that's another development that needs to be addressed in the calculator. Not yet, but it will be.
Thank you. One from Adam Grant. How does the calculator assess moisture and permeability of materials? I understand the Glaser method is quite limited, especially with natural insulations.
Again, as I said in the presentation, I'm only looking with the condensation check as a means to identify a problem rather than trying to say this is a good solution. That is beyond me at this stage, and I'm sure that I can do a Glaser calculation, but actually what you need to do is go to Woofy and Delphin and do the proper calculations thoroughly for your building. There's no sense in kind of trying to do it with a single BS5250 calculation. It's just not going to work.
Okay, and one last one directly for you, Brian. Alina says, thank you for the presentation. Can't wait to use the tool. And I think that goes for a lot of us. It's what we all need. And this is a specific kind of STBA SPAB conference question. Regarding upgrades to Windows, there are some studies taking into account retain and repair of existing windows combined with secondary glazing, curtains, blinds, etc. Would this type of choice be included?
Well, the English Heritage Report in Edinburgh did a kind of good study on that, and that kind of information I'd love to include. So I'm reliant on STBA and SPAB to kind of guide me on the information that's available, and then we'll build those, not just new window calculators, but the whole secondary element calculation for the existing windows. So that kind of little snapshot of how I thought the individual measures calculator can address that in much more detail. We just need to get the available data and then get on with it.
Okay, I think that could be very valuable. Sophia, one for you here. Antonia Kayat asks, what percentage of LPGs today are bio-LPGs? And also she adds, what percentage of bio-LPG is imported at present?
No, so good question. The majority of bio-LPG, sorry, that's used in the UK today is imported. So two examples of where that can come from. So one is from Neste Refinery, biorefinery, which is in the Netherlands. They're producing a biodiesel through vegetable oils as part of the HVO process, and we get bio-LPG from there. One exciting example, which isn't currently where we get it from, but it will be in the next year or two, is another exciting kind of project, which is through with Dutch Airlines, KLM, and Sky NRG, and they're going to be processing used cooking oil with hydrogen, and they get bio-LPG as a co-product from there. So that one is going live not next year, but the start of the year afterwards. So that's kind of a advanced example. There are other areas where we get bio-LPG from, but a lot of it's wrapped up in commerciality, which as the trade association I can't talk about, so I don't mean to give a bit of a cop out on that, but it's just quite difficult for me to talk about. But what I can do is and I'll share it perhaps afterwards with the slides, is a link to a study that we had done independently. There's a lot of information in there, so anyone with particular questions on that I can share from there.
Thank you, Sophia. Tom, one for you. Mary Han asks, has anyone looked at lime stabilised clay and hemp? Because you did speak about clay a little.
I don't know. The clay that we're currently using seems to do the job perfectly well without us needing to add any lime. But okay. We've done some mixture 50-50 of lime and clay, and then we just did it with clay, and but we might need to add lime, for instance, in terms of weatherproofing. I don't know how weather resistant it is, so there's a lot of work to do on this. Yeah, it's still early days.
Okay, thank you, Tom. Brian, I think another one for you. Francis Volkers asked, in our climate, much wetter and windier and milder than most of mainland Europe, our RH relative humidity is always very high, often 75%. So condensation on cold surfaces is always a high risk. So that condensation, and you mentioned you were adding this, needs to be added when possible. You also mentioned BS5250. That, of course, is being updated at the moment. Just wondering whether you were bringing that into play.
Well, yes. I mean, again, if you really want to get to the bottom of moisture movement, hygrothermal moisture movement in buildings, you've really got to go to Woofy and Delphin. And some of the manufacturers and suppliers are offering those calculations on your behalf in order to support the sale. So, surface materials, interstitial materials can all be looked at more thoroughly. including things like orientation, weather, all of those things can be taken into account. My calculation is really basic and very simple. So if I could do Woofian, I would add them in, but I know damn well that's not going to be possible. Their spreadsheets are bigger and more powerful than mine alone, so mine would just become completely unwieldy. So the important thing then is understanding the climate and making sure you make the material choices for the right reasons. So adding the climate module, climate specific module or climate appropriate model, then I will begin to address those things, but that's not planned until much later.
Well, it's already pretty sophisticated, so that will be gilding the lily, but thank you for that, Brian. Peter Cox, one for you. Philippa Gould asks, do any of the case studies compare time, quality and cost assessments as well? And Trudy Hughes adds that this is an elephant in the room, it needs to be considered.
We did. We looked at time and cost, and in the bigger report, she'll find that. Do you want me to send you a link to it, or you can get it on the Historic England? I think it's called Heritage Counts.
Oh, the Heritage Counts one. Yeah. Peter Draper, how are we sharing any follow-up information? What's the best way of doing this? You got
people. Yeah, people will get copies of the slides from this, and if there's any extra information from the questions that the panelists can send to us, then obviously we can then mail that out through SPAB to all the participants.
The chats are quite useful as well. If there are questions and answers, the chats are quite useful too.
That's great, thank you.
Yes, we haven't had very much in the chats. We've a lot more in the questions. I assume probably we can share those questions and answers as well. That functionality, I'm not sure, but I'm sure it's possible.
Yep.
Okay. Thanks, Peter. Soki has got a question for Tom. She says she'd like to get in touch to discuss clay binders for hemp insulation. So I think she'll do that directly. But she also asks Brian whether we can start to work on a bespoke LCA on benign window improvements. And of course, this builds on the work that Historic England did some time back.
Yeah.
Okay,
yes,
so
well, my answer is absolutely. The sooner we can kind of develop specific parts, the more useful it becomes.
Okay, yeah. So
I didn't catch the name. Who was the person asking that question?
That was Soki Reed-Duverne of Historic England.
Oh, right, okay.
But I'll put you in touch afterwards because it's something that we're looking at anyway.
Great.
Thank you. Yeah.
And I have another one, I think, for Brian from Jo Atkinson. She asks whether the calculator can give the result of do not use for incompatible insulation materials, e.g. for a traditional solid wall based on material type and also embodied energy, as already discussed.
Okay, so the answer is the collecting of data from manufacturers will require them to identify where a material is to be used in the construction. It will therefore, in the spreadsheet, in the way I structure the spreadsheet and the lookup tables, you will only be able to use a material in the way it was intended by the manufacturer. So it won't be offered to you in a drop-down menu if it's not appropriate. But it's reliant on manufacturers, understanding the appropriateness of their material to a particular construction. You still see manufacturers and manufacturers association promoting materials in applications and in wrong locations that are fundamentally wrong. And the only place they'd be suitable would be in kind of Africa, where the atmosphere is different to the UK. So it's a case of you won't be offered the opportunity to use the wrong material in the calculator. At the moment where it's manual, you can paste in anything. At the moment, but that should be fixed in Rev 2 issue.
Thank you, Brian. I think at this juncture, I'm going to call this morning's proceedings to a close. It's been a fascinating morning. And firstly, thank you to all our speakers. It's been terrific. And thank you to everybody for attending. And we've had some excellent questions. I think many of you we shall be seeing on Thursday. Most of you are coming along to our second session on Thursday. So we shall look forward to seeing you virtually at that stage. So thanks again.
Well done, Nigel, for organising it. Thank you.
Yeah, wonderful.
Thank you very much.
Thank you very much.
Bye.
Thank you. Thank you.
Cheers. Bye-bye.
Bye.